So, hello everyone, welcome back to the another session. This is the chapter 5 of LLD series. So, in this chapter, we have to understand what is a solid principle in the LLD that are we using. Okay. So, first of all, we have to understand what is solid principle. So, solid principle are the best treated as a pressure test for your model. So if you write a particular code, so if that it's follow the solid principle, that means that your code is running like in a correct way. Okay. So like solid principle are the best way, like best treated as a pressure test for your model, not a decorative levels. Okay. You don't like do by unnecessary thing. Like it is like a decoration. No, it have some specific thing. So it handle your because your model handle that thing. Okay. So in this chapter or in this lecture, we can say that so how to use them that way. Okay. Or in this chapter, you will apply each solid principle in a practical LLD scenario. Okay. Recognize when principle is being forced or unnecessary. Okay. So like as I said earlier, in LLD series, we are like learning most of the important like tools, like important topics. This not mean that we can use anywhere. Okay, unnecessary. So if you recognize the principle like being forcefully like force unnecessary. Okay, you can see in many of the like cases. Okay, so also discuss the trade-off instead of reciting the textbook definition. So we see we see how like this thing happen, instead of like just I'm speaking this thing is not do, this thing have to not to do. Okay, all this thing. Okay, so solid is not a magic formula, but it is extremely useful for evaluating whether the design is rigid, fragile, or hard to extend. Okay, so these are the test by the solid principles. So starting with first, that is S. This is the first principle that we stand for the S, that we call single responsibility principle. Okay, single responsibility principle. Okay, so definition wise, we can say that a class should have only one reason. So we have like we make a class, different classes. Okay, so we have class, and class should have only one reason to change. Okay, this does not mean that a class should only have only one method. Okay, like we make a class. Okay, and the class have some things that like have some methods inside that one. So some particular methods, but don't mean that like this class have only one method inside. There are too many methods. Okay, but having the single responsibility. So if you have calculate price and a percentage check, so all this happen in the calculator things. Okay, so this is the a single class in which it do some specific task. Okay, have a single responsibility. So having this class having single responsibility, so that's why it's known as. Okay, so it's mean that a class should have responsible for only one thing. So keep in mind that why I'm specifying. So having class have to do only one thing. Okay, if a class is doing multiple unrelated, like not multiple plus unrelated. Okay, so like be specific if I'm like talking about the something, so be focused when I am using the terms or not. Okay, so I am saying that multiple unrelated jobs. Okay, so these two things we have to like understand. If a class doing multiple unrelated jobs, so it violate the SRP rule. Okay, let's understand by a bad example. So if we see some bad example, then we understand why we are not using this one. Okay, so we have a order manager. Okay, so class that is order manager. Okay, so I'm using the Java language. I am like specifying this all the code in the example of Java, so you can understand in the C++ when I'm like practicing all these things. So I will explain this in C++ too. Okay, so first is the order manager is the class. Okay, so we have a order manager class. Okay, what is the size of this one? So let's so order manager class. Okay. Same with we have public void create order. So this do some one task. This is the one task done by the order manager. Another one is that it void process payment methods. Okay. This is the another task done by this class. Okay. Third, public void assign delivery partner. Okay. This one is the third task. You see, like public void send mail. This is the like fourth task. Okay, fourth responsibility. And public void save to a database. This is the fifth responsibility of this class. Okay, so as at the first class, this look fine that this class manage whole the like whole responsibility. But ask yourself, so what is the responsibility of the order manager? Okay, so if I am a user, if I am like a reviewer, so I am asking, what is the specific task that this order manager is doing? What is the responsibility of this one? So like one person said that it created the order. Okay, it's true. Another person said that it processed the payment. It's also true. It assigned a delivery partner. It's also true. And send the email. Okay. And save to database. So you can say this man can do a multiple task. Okay. They don't know the what is the actual responsibility. Okay. So let it's doing a 5 different job. Okay. So this make me think like this make us to think that this we have to make a class to do one responsible task. Okay, the responsibility one that is like order creation. So we are seeing that it created the order. This method create an order. For example, so customer buy the laptop, mouse or keyboard, the order is created. So like we have order like create order, so order creator. Tomorrow if tomorrow the order creation rule if tomorrow the order creation rules changes, the only logic should change. Okay, so only the logic should be changed, not the whole like classes. Okay, a second thing that we have a like responsibility, that is process payment. Okay, process payment. So this has nothing to do with creating an order. So like we don't like we know that earlier like methods do creating a order, but this process payment is nothing to do with that earlier method. So okay, so like for example, if these are the UPI, credit card, like by what are the payment methods? We can say that like through UPI, credit card, net banking, and the wallet you can do. Suppose tomorrow Razor Pay API changes, so only payment code changes. Okay, not the order creation things. So why should order manager change because of the payment? Okay, so like it's a matter of thinking that why this order manager changes because of the payment are like get updating all this thing. Okay, and we had heard that responsibility, that is assign delivery partner. So in which first of all assign which delivery partner, Blinkit, Swiggy, Dunjo, Blue Card, where we have to assign this. Tomorrow your company changes to Swiggy to delivery, again one delivery logic we have to change, and why to modify this? Like these are the question we have to think about. Why this order manager have to modify? Think. Another that is method, that is the like send mail. Okay, so maybe the today is the email method, but tomorrow like it's include the WhatsApp method, the SMS and the push notification method. So notification rule changes again. Okay, and so in that case you have to make changes inside the order manager. So why? Again, the fifth responsibility we have, like save to database. Okay, today we are using MySQL. Okay, tomorrow we move to like shift to the MongoDB. Again database change. Okay, so an order manager have to change. Okay, the problem we understand different methods and different tasks they are doing, but the problem is one class change because of the order like changes, payment changes, delivery changes, email changes, database changes. So we are seeing that we have to change this class by like different time, different functionality are changing. That's mean that 5 different reason to modify one class. Okay, so keep that wording, 5 different reason to modify one class. Okay, so this violate the SRP rules. Okay, that is single principle, single responsibility principle. If you have a single responsibility, only one, like if you have a single responsibility, so if one thing changes, then this get changes. If you have like multiples of tasks, then it become a matter of concern. So taking a real life example. Imagine you have a restaurant. Okay. So imagine you have a restaurant. Okay. So one employee that take the order. Then another one is like food cooking. And another one is cleaning the table. Another one is like collecting the payment and then delivering the food. Okay. So will this scale? Okay. No. Like, because if one person take the order. Okay. So like this person is like going to this table. Okay. And after this table is go to kitchen, going to table and then go to kitchen, then again go to like collect the plate and then serve on this table, then again go to kitchen, then collect that thing. So like this is hard to like manage different table. Okay. Hard to manage the different table. Okay. So we can say that no, we can't scale this by using one employee. So every employee have their own single responsibility. So we can say every employee should have one single responsibility. That cashier have their own responsibility, chef is another having own responsibility, writer have their own responsibility, cleaner have their own responsibility. So everyone does one task or one job. We can say everyone does one job. Okay. So what is the better design? So what we can say in the better design? So better, instead of one huge class, split their responsibility. What is the solution? Like instead of like having the huge class, we split the responsibility. Like respond like order the services, payment services have the different class. Okay, delivery services, notification services. Okay, database services. So each class has one job. So each class follow one job. Okay. So let's write the write one by one. The what are the jobs we have to what are the different jobs we have to write. First of all, we have the order services class. Okay. So class order services, inside this public order, public order, create order, cart, and like create some order and return null, and this is one cart. So one is only responsible for the cart and the order. Okay. If you put any item, it get order. So if our order creation changes, only this class has to be changed. Okay. So if I change this order, so in this class we have to do some modification. Okay. This is the logic of this code. Okay. Then move to the payment services. We have to make the different class. So the class payment. Okay. So in that class, a public payment result process order, like inside the order class, we take that order. Okay. Payment method, what are the different payment method, and then we have return. So only responsible for the payment. So we can say that order is created, then we have to pay whether it is success or failure. Okay. Same in the delivery case, we have the order, then we have to deliver. So in that case, we have the order, then find the nearest delivery partner, then assign. So only responsibility of assigning the delivery. So for the notification, we have like a public void notify customer. We have that order, then we have to notify what are the string we have to only responsible for notifying the like emails, through emails, SMS, all this thing. Okay. And database services should not could also be like a order repository. Okay. So what is the flow? What is the flow? Flow when someone like order the pizza. So what is the flow? First of all, imagine you order a pizza. So first of all, customer order the order service. Through order services, it created an order. Okay. After that, it moved to the payment method. So payment services which process the payment. Okay. After that, the only task that payment services are doing. Okay. After that, delivery services we have. Then it assigned the delivery boy. Okay. After that, after assigning the delivery boy, the notification services is like enabled and it reach to the user and it send the SMS. After receiving the SMS, we have order repository that are saved in the database. Okay. Notice that every classes perform one clearly defined task. Okay. So this is known as a single responsibility principle. Okay. Why single responsibility principle is useful? for easier to maintain. So it is easier to maintain the bug in the payment. If that bug in the payment, so we can fix it. Only the payment services had to check. No need to touch the delivery. No need to touch the delivery, delivery things, all this thing, assigning all this thing. Okay, easier to test. Okay, and you can test the payment separately. Test the payment which passes and delivery doesn't matter. Okay, easier to reuse. Suppose another application only need payment, we made another application that need the same logic that we are using in your application. So suppose another method. So if we use this class, class is a blueprint, so you can directly use this payment service. So no dependency or no order creation are required. Okay, easier to extend. If I want to in future, if I want to add the Google Pay and this only update happen in this payment services class. Okay, so everything stay everything else stay unchanged. So fewer merge conflict happens. So if one developer work on the notification and another was working on the payment, so that they modify the different classes instead of the both editing the order manager, it's reducing the code conflict. So it will help in the production side. So what is the interview tip I have to give? So if asked, so what is the single responsibility principle? So the good answer is that a class should have only one responsibility and therefore only one reason to change. If a class handle multiple unrelated tasks like payment, notification, persistence, so it become harder to handle, test and extend. So we should separate these concerns into a dedicated class and each responsibility for the specific job. Okay, so you have to answer. Okay, so this explanation along with this order services, payment services, delivery, assign services, notification services example explain, demonstrate a solid understanding with the SRP in the low level design. So this is all about single responsibility principle. Okay, in future we have to write the code on this one, so we understand what is the logic, what is the key things inside the SRS. So we are doing this solid principle. So we completed this part, that is S. Okay, so we move to that is O. Okay, so O stand for the open close principle, open and close principle. So what does it mean? Okay, so by definition wise we can say that software entity, that is a class, methods and modules should be open for the extension and but close for the modification. What does it mean? Open for the extension, and the close for the modification. So this means that you should be able to add a newer functionality. So it means that you should need to add new functionality. Okay, and you should able to add new functionality as we discussed in the earlier example. We have at payment services in which now we are using Paytm. So if you want to add a feature Google Pay, so we can add this new functionality. Okay, and you should not modify the existing. So you have to not modify the existing test coded every time with a new requirement comes. Okay, so we don't have to modify the existing code, we simply add the new functionality, don't need to change the existing code. Okay, so this think of it don't change old code, add new code. Okay, for example we can say that this is a room. Okay, so these are the bed alignment. Okay, so this person are sitting in this bed. Okay, this guy is sitting on this bed. So make our class or a room is in a such a way that we can add a new bed inside. Okay, we don't have a space, and if we don't have a space and we try to fit this this thing. Okay, or you want to remove this guy and this fit this double bed. Okay, we don't do that. Okay, so instead of touching the existing code, we add a new functionality. Okay, so real life example we can say that I am also giving that. Imagine a phone charger. Okay, so you buy a phone that has USB-C charger. Okay, and later you buy an iPhone. Later you buy an iPhone. Okay. So do you redesign the design the wall socket? You said no. I don't design the wall socket. Your wall socket have a specific charging point. Okay. So we can say that answer is no. You simply you simply use another compatible adapter for this one. So we know that different type of chargers for the Apple and this like normal phone. Okay. The socket remain unchanged while the new accessory extend this functionality which use the different adapter for this thing. Okay. So this is exactly what is the OCP, encourage open close principle. Okay. You can add the new functionality but don't modify the existing code. Okay. So let's see understanding with a bad example. If you see, so class payment services, like we have a class like that we call it payment services. Okay. And in this class we use like public void pay string. So this is a bad example we are taking. So if type is equal to card, type is equal to card, so in that case we use card payment. Else if type is equal to UPI, in that case I use UPI payment. If type is equal to wallet, so I can use wallet. Okay. So suppose your application initially support the card payment, but in future like we are using that card payment is like available in this thing. Okay. So but suppose your application is like card support, later the business said that I want to add this UPI methods. So you have like you modify the class, like in this case like you modify the class, add this else if is equal to else if. Okay. And then they said add a wallet, so modify the class once again. Okay. Then add net banking, again you have to modify the class. Then we have to add PayPal, so again we have to modify. So we can say that every new payment method require editing the same class. Okay. What happen every time, like what we can add, but what happen every time? So initially if card, so then card. Okay. Later if card, else if UPI I use, again else if wallet. Okay. Again else if UPI, else if wallet, PayPal, net banking, Apple Pay, crypto, all these things. So the class keep growing and this wallet less class become keep growing. Okay. So this become a messy and the class like keep modifying. Okay. So this violate the OCP because every new feature modifies the existing code. Okay. The problem with this design is that high risk of the bug. Okay. So in this like so you think that what is the problem with this code? So we can say that it's a high risk. We will face a high risk in like high risk of the like how to solve this bug. Okay. So while editing, like if they accidentally remove if statement, type is equal to this one. Okay. So if I remove this thing, okay, if card, why it's not, okay, if I remove this thing, now the card payment stop working. Okay. And one small changes can break the old functionality. Okay. So if I remove this thing, so like card payment stop working and the like small changes break the old functionality and difficult to maintain. So it is like difficult to maintain. Okay. So like this one is like difficult to maintain, like hundreds of like we have hundreds of payment method lead to a giant change of condition if else if else if else if else. We like finding the bug is difficult for that time, so like it's difficult to maintain. And it also violate the OCP that instead of extending the functionality I am just editing the same class. So this is like violating the instead of this one extending this functionality. So this violate the our OCP. So what is the better design? So like better design we have to follow this thing. So instead of putting every payment method inside the all class, we create an abstraction. Okay. So interface payment processor. Okay. Okay. Payment result. What is the payment result? So payment processor, which type of payment I want to choose and what is like payment result after that one. Okay. So every payment will implement this interface. Okay. So every payment will interface like implement this interface. Okay. So let's see with example. So I read this like payment processor and that payment result will be like success or like failure. Success and failure. So first of all, we have a card payment methods. Okay. First of all, if I want to like see the card payment method. So what is inside? So class card payment that implement the payment process. Okay. And override the payment, like override that I'm using like payment result. So public result pay order. Okay. So return if that thing happens. So return payment dot payment result dot success card one transaction. Okay. Okay. Only responsible for the card payment. So this class implement this abstraction, this class, like instead of putting the item inside the one class, so every payment method would implement this interface. Okay. So this is the one task. Okay. Again, I want to like use this UPI method. So class UPI payment processor implement payment processor. Okay. Override this payment pay order. So if it is like if it is success, then it will say that UPI transaction one happened. So only responsible for the UPI. Okay. If I have a wallet, so if a wallet processor wallet payment processor implement the payment processor which override the public payment result order. Okay. So that return the payment result success from the wallet. Okay. Okay. So you notice you do not need to modify the card payment processor. So this is the like first, this is the main. Okay. This we call it a payment processor. Okay. So you have noticed that we don't modify the card payment processor. We don't modify the UPI payment processor. We simply add a new class. This is what we call as a OCP. That we call as a open for the open for the extension but close for the modification. Okay. Here we can say that like payment services look like class payment services private final const map payment type with the payment processor. Okay. And that is the processor. We have the map. After public payment services, we have like payment type plus payment processor. Okay. So we have two things. So this processor represent this thing. So we have payment services and public payment result pay payment result pay. So order type and payment type we have like the we are creating the object. So payment processor, this is the one object processor to get the payment type. Okay. A processor is null. So throw new illegal argument exception supported payment support. Okay. And return the processor dot pay order. Okay. Let's understand step by step. If all the processor that are like store all the processor we have keyword, think of a map of a dictionary. So we have payment type. Okay. So we can see that a payment type we have in this like card, UPI, all this thing happen. So this having the different type of the classes, the own responsibility classes, card payment, then UPI payment processor and the wallet payment processor. So first of all we created. Then after we created a constructor that is a payment services. Like we created payment services in which we map a payment type that we created and the payment processor. Okay, and that is known as a processor. Okay, so this processor represent as this processor. Okay. When creating the services, we just inject all the available processor inside this one. So in that case, we have to like see that this map dot payment that is equal new hash map. So map dot put this payment type card to new like card payment processor. Map dot put that is UPI to new UPI processor. Map dot put this wallet to new wallet like wallet processor. Like payment that is services is equal to new payment services. Inside this map we put that map into the new object. Okay. Now the service know which processor handle the each type of task. Okay. Make a payment. So like payment processor, this process and like processor to get the payment type. So if I select the UPI, so like get the payment type. So if I select the UPI, then the map return the UPI payment result, and if the user select the card, then the map result the card payment processor. Okay. and delegate the work. So return the processor dot pay order. So instead of checking if else condition, payment services simply ask to correct processor to handle the payment. Okay. What if tomorrow we want to add the PayPal? So first of all, create a class that is PayPal payment that implement from the payment processor. Override that we have to result pay order. So return this PayPal. Then register into the map. So map dot put payment dot type is PayPal, and the new PayPal use this like this method. Okay. Done. No need to change the payment services. No card, and no need to change the card. No need to change the UPI. This is open for extension and the close for the modification. So this is the way simpler than you think. Okay. So like design flow, if you said how the design flow look like, so design flow look like we have a customer which follow the payment services. First of all, processor to get which payment to processor to get type. So processor to get the type. So which processor, which process, through which process he want to pay. If he want to like pay from the card, so it will follow this tick part. Okay. If payment result successful, it will return the successful part. If it follow the payment UPI payment method, so it will show the payment result and this gets successful. If it follow the wallet payment method, so this will like this game. Okay. So this is as much simple you think. Okay. And you think why use an interface? Okay. Without an interface, if card type is equal to card, okay, like we have to write type is equal to card, or with interface we can set a processor dot pay order. Okay. So payment services don't need to know how card or UPI payment work. Okay. This only know every process can perform pay method. Okay. This make load flexible and easier to extend. Okay. No need to do how this thing happen. Okay. So what is the advantage of OCP? So easy to add new feature by creating a new class. Reduce the risk of breaking the existing code. Like we have to test the code. Cleaner code without if else switch condition. Okay. Easier testing since each payment process can test it independently. Okay. Better scalability, especially when the number of supported payment services grow. Okay. Let's come to the final thing, that is what is the interview for this one. Okay. So if someone say that explain the like open close principle, the strong answer you have to answer that is the open close principle state that the software entity should follow open for the extension but close for the modification. Instead of modifying the existing code, whenever a new feature is added, we design the system using abstraction like interface. Okay. We design the system using the abstraction. So in this payment example, each payment method implement the payment processor interface. Okay. Adding a new payment type only required for creating an implementation and registering it, making without changing the existing payment services. Okay. This reduces the risk of introducing the bug and making a system easier to maintain and extend. Okay. This is all about OCP. Okay. OCP, open and close principle. Okay. So we first created the single responsibility principle, then it is open close principle. Okay. So we have like completed SOLID. Okay. So we have studied this S, we have studied O, and now we are going to study this L. Okay. And this 2 will be covered in the next lecture. Okay. So what is L? Liskov, what do we call? So like what? So we can say that solid principle L. So L stand for the Liskov substitution principle. Okay. That is LSP. So I have to write at this place. Okay. So we can say like we can Liskov substitution principle. So what is LSP? Okay. So what is LSP? So by definition, the object of the subclass, should be replaceable with the object of the superclass without breaking the correctness of the program. Okay. So we have the class. Okay. So through which we created a object. Okay. An object having some or also having a sub classes. Okay. So subclasses we have. So should be replaceable with the object of the superclass. So this is the object object of the superclass. Okay. So it can be replaceable with this thing. Okay. Without changing without breaking the correctness of the program. So we can say that if a class B, if this class we have class B. Okay. So class B extend a class A functionality. So this class B have follow this A. This class B extend all property of A. So whenever A is expected, B should work correctly without changing the program behavior. Okay. Whenever A is expecting, so B class perform correctly without changing the program behavior. A simple example I want to show you here. Suppose we have an animal class. Okay. And dog that extend the property of this animal. Okay. So if a function expect an animal, expect animal, then passing a dog class should be work. Okay. So for example, void print animal in animal class. Okay. So animal dot make sound. Okay. So it passing a dog. So print animal, that is new dog. Okay. Work correctly, and this follow the LSP. Okay. So understanding with the rectangle example, we have rectangle. Suppose you design a rectangle in which we have given this access modifier for the width and this for the height. Okay. And we created a set width. We have to add the int width. This width is equal to this width. Okay. Public void set height to this height to is equal to this height. So if a rectangle has two independent property, that is width and height. For example, width become 10 and height become I have to set 10 and 5. Okay. And you want to change them independently, like rectangle dot set width is equal to 20 and rectangle dot set is equal to 10. So final become this thing. Okay. Okay. So then we don't think that if we add one feature, so we can't change in the future. Okay. So this is the correct example. Okay. So suppose we create a square. So many beginner think that square is a rectangle. So so they write square, class square extend the feature of rectangle. Okay. The look logical because schematically a square is also a subpart of rectangle. But in programming, this cause a problem. How? So square implementation, or how the square implementation? So class square extend the property of rectangle. Okay. And it override the feature of setting the width. Okay. So in width, class. Okay. So class void set width int width. Okay. So this width is equal to width and this height is also become width. Okay. And override another property, that is set height. So this is equal to height. So this width is equal to height and this height is equal to width. Okay. So noticed anything? So that is the new thing that you notice, this part and this part. Okay. Whenever the width is changed, the height is also changing. Whenever the height is changed, in that case width is also changing, because the square must satisfy this condition, height is equal to width. So let's test it. Suppose a client code expect rectangle. So rectangle R is equal to new rectangle. Okay. So this we created an object rectangle. Okay. So I set this rectangle height is equal to 10 and set the rectangle width is 10 and rectangle height is equal to 5. Okay. The result will be 10 and 5. So okay, it's correct. Now replace this rectangle with this square. So now we have to take rectangle in the rectangle class. I R, that is follow the property of square. Okay. If I set the width is equal to 10. Okay. And now we set the height is equal to 5. So now it become 10 height and width, and it become 10 height and width, and it will become 5 and 5. So let's execute. So set width 10 become, it internally give the width is equal to 10, height is equal to 10. Okay, and the current value become 10 and 10. Okay, step 2, when I set the height is equal to 5, then square override these two, like width is equal to 5 and height is equal to 5. Okay, the final result look like width is equal to 5 and height is equal to 5. So but what did the client expected? Client is expecting that the width become 10 and the height become 5. Okay, but instead we got width is equal to 5 and height is equal to 5. So this behavior change unexpectedly. Okay, so this behavior change unexpectedly. Why this problem occur? Because imagine imagine another method, like we have imagine another method, that is like we are talking about the area. So we can say that public int we want, and the class name is the function name is area, in which follow this rectangle class, and we pass this object. Okay, so rectangle dot set width is equal to 10. Okay, so the width become 10 in this case. Rectangle object, I set the width is equal to 5, then it become a 5. And now I want to I want that, and I want to print the area. So how it's become? So return from rectangle dot width, I extract the value 10, and rectangle dot height is equal to, we extract the value 5, and then we multiply, so it becomes 50. So answer is equal to 50. So till now everything seems to be correct. Okay, now this time we have to pass in area, we have to pass the new square. Okay, okay, so execution become set width is equal to 10. So in that case width and height both become 10. And if we set a height is equal to 5, in that case width and height become 5, and the area become 25. But we are expecting 50, but actual area is equal to 25. So this the program break it, and this violate the Liskov substitution principle. Why does it violate the principle? So this method was written for the rectangle, and it assumed that width can change independently and height can change independently, but square changed that rule, and therefore square cannot safely replace this rectangle. This means that square is not a substitutable for the rectangle in this design. Okay, so real life analogy, we can say that imagine you have a TV remote. So your TV accept any remote that follow the expected behavior. Okay, your TV only follow the expected behavior. Okay, so suppose someone give you a special remote. Okay, so whenever you do volume plus plus, so this will change the channel. Okay, so you should you would be happy? No, you should not happy. So remote technically, so the remote technically has all the same button. Okay, but behave differently. Okay, so it cannot substitute as a normal remote. So this is exactly LSP violation. Okay, so you think this guy having same feature, these are the human also studying from the, this student is also studying in the BTech. Okay, and this student also study the BTech. Okay, so this is from the civil, and this is from the CS. Okay, and you give some laptop, okay, to do some task. Okay, so this guy can do and give the output, but when we this having this all the functionality like same guy, but if you give this laptop, this guy don't do that work. Okay, so we can't substitute in this place. So this is a violation, and this is called Liskov substitution principle violation. Okay, so what is the better design? What is the better design? Instead of forcing the inheritance, okay, rectangle's property is inherited by the square, we create a separate abstraction. So we create a class that share the common abstraction. So interface shape, okay, interface shape integer area. Okay, we create one class and rectangle class. The class rectangle implement this shape. Okay, class rectangle implement that shape, and this is the private width and the private height. Okay, so public rectangle we have int width with in integer width or height. So this width become this width, okay, and this height become this height, okay. And another thing that is override the area, okay. Rectangle, implement all this thing, having private all this thing. We created a constructor, then override this property and added override. So public integer area, and this will return the width into the height, okay. Okay. Now we created another class that is square, which implement the property of shape. We have the sides, okay, square, like public square inside, and this side represented this particular side, okay, and which override the area property. So public int area, so return side into side, okay. So both classes implement the same interface but maintain their old behavior, okay. Okay. So these two classes implemented from this shape class. So you can see that this is the like father, okay. So it from father it implemented and gave the correct output, and it also implemented from the and give the corrected expected output. So this is the flow, okay. So what is the flow diagram? We can expect that we have a shape through which it implement. So it will be implements, okay. Like this is square, so this rectangle implement this area property and give this one, and through this square also implement this shape property and give area. No incorrect inheritance, no broken behavior, and LSP is satisfied, okay. How to identify an LSP is violated? So ask yourself, can I replace this parent object with this child object without changing the expected behavior, okay. So whenever you, how to identify this thing? So can I replace this parent object with this child object without changing this, without changing the expected behavior? So in that case, you have to answer. If answer is no, then inheritance is probably the wrong choices. Okay. In that case, you have to use the implementation. So what is the advantage of LSP? Why we are like focusing on this LSP? Okay. The class become predictable. Okay. And parent-child relation remain correct. No unexpected behavior in a client code. Okay. Easier for testing and maintaining, and better use for the polymorphism. Okay. So interview tip. Let's see what is the interview tip for this one. So if interview asks, explain LSV, that is Liskov substitution principle. The strong answer is that Liskov substitution principle state that the subclass, okay, the subclass that are the like rectangle and this thing, should be usable whenever its superclass is expected without changing the correctness of the program. Okay. Classical example is the rectangle and square. The rectangle allow width and height to change independently, but the square force them to become equal. So replacing the rectangle with square. So replacing the rectangle with the square changes the program behavior unexpectedly. So violating this is like LSP. So in such cases, inheritance is inappropriate, and both classes should instead implement common abstraction like shape. Okay, this is the solution. Like implement common abstraction, that is shape. So till now we have finished reading. We have finished this S, this O, and L. So in next session we have to see the L as IND. So we have to see that is this is I, so interface segregation principle, and we have that is D. So D stand for, like, see what is D. After finishing this one, D, that is like dependency inversion principle. Okay. So see you in the next class. Bye bye.